Okay, you're welcome back to Integrated. This is Mathematics. Okay, today we're gonna talk about a very important coordinate system that's called cylindrical coordinate system. Later in this video sessions, we have to talk about the cylindrical coordinate system also. First of all, I'll explain you what are the usages of this at what kind of times we need to use this. When you're dealing with the chemical engineering procedures, you need to use this. You need to apply this cause most of the atoms and the molecules have a spherical shape. Okay, therefore you need to study the motion and the other characteristics of the. So you need to use the spherical coordinate system, just like that. And if you talk more and more, when you are doing and momentum, and just like the volume, when you do triple integral, that would be more easy to apply the spherical coordinate system and cylindrical coordinate system. Let's talk about what are the relationships that's related to the cylindrical coordinate system at the very first. Let me show you guys what's the cylindrical coordinate system and what are the more important theorems that revolves around it. Okay. I'll try my best when I am figuring out when I'm drawing figures. Okay. This 3D and this 3-dimensional plane. Hope you guys may see this x, y, and z. Okay. This vector that is along the opposite direction. Okay. Let's call it as vector r. Okay. Vector r has been formed. This is vector. Let's call this as vector rho. Okay. This is vector rho, and as usual, this is vector z. Okay. Let me describe all these things and all these expressions. Let's call this angle as theta. That's measured from x-axis to the vector rho. Okay, and the next we need to this is the identity vector. This is the unit vector that's along the rho vector. This is called as rho hat. Okay, this is perpendicular to this plane because that is measured to the direction of the increasing of the theta, increasing of this angle, increase of this dot. Okay, that's why this is called as theta hat. Okay, this is the unit vector along that direction. Okay, and next this guy, you guys, what's this? This is along the z-axis and the z direction. This is z hat. Okay, the very first we need to know what are the relationship between these 6 guys. Okay, when you are dealing with triple integral, you need to know what's the relationship between these 3 guys: dx, dy, dz, and the d rho, and the theta, and dz. Okay, let's see. Dx, dy, dz is going to be equal to the the determinant of the Jacobian Matrix times d rho, d theta, and dz. Okay, let me show you what's the Jacobian Matrix. Actually, I need a couple of videos to explain you guys all these theorems, because there are a few things to be explained. with the especially the del operator that's related to the cylindrical coordinate system. That would be a little bit complicated. It should be derived step by step. You guys need to understand all these steps. Otherwise, actually, you no need to memorize all the. Some guys used to recite all these things. That's not necessary. At any of the time, you would be able to draw all these things. Okay, I'll teach you how it's going on. This is Jacobian Matrix. What's Jacobian Matrix? How it comes? Partial x, y, z with respect to partial x, y, z with respect to what are the three other components? Partial rho, let's say partial the rho, theta, and the other guy z. Okay, this no need to be confused. Nothing else. This is the determinant of the Jacobian matrix. Partial x with respect to rho, partial x with respect to theta, partial x with respect to z, partial y with respect to rho, just like this. It flows. Okay, you may see the pattern. Okay, partial y with respect to z. I use my flasher because I'm just using a very, very primitive app because I have no memory inside of my device. Partial z with respect to rho, partial z with respect to theta, and the rest partial z with respect to z. Okay, this is the Jacobian matrix. If you the determinant of this matrix, you may find out the Jacobian matrix, the determinant of the Jacobian matrix. That's the thing you need to find out. Okay, I'll show you how to calculate it. At the very first, you need to find out all these guys. Okay, so when you are evaluating these elements, you need to know the relationship between these six guys. Okay, I'll show you how to do it. That's very easy. That's pretty easy. This is the x-axis. So x can be written as how it can be written. This is the magnitude of the x vector, and no need to use the vector at this moment. Okay, x is equal to rho cos theta. Okay, rho cos theta, and the y is equal to rho sin theta. Okay, and the c is nothing else. Z is equal to z. Okay, by using these three guys, you are able to evaluate all these nine elements. Okay, I'll show you how to calculate them. At the first, partial x with respect to the rho, partial x with respect to the rho, partial x with respect to the rho. Okay, it means that's equal to cos theta. Partial x with respect to the theta, that's equal to minus rho sin theta, Okay, partial x with respect to z, that's equal to 0 because there is no z elements there. Because we consider it, no need to explain. That's the partial derivative. Okay, it's like this. You need to find out all the other six guys also. Okay, by the next video, I have to continue other tasks. Okay, especially how the del operator comes, and how I can I use it to write the Laplacian. And how? What about the divergence and the curl? Okay, there are all these things. If you guys have any of the question, any of the doubt related to this one, please put your comments on our video. Okay. Uh, thanks for watching. This.